We all want technology that feels made just for us, from smarter keyboard predictions to personalized health advice. The challenge is that for AI to get truly personal, it needs to understand our unique data. But how can it do that without collecting all our private information on a central server? This is the promise of federated learning, a technique where AI models are trained directly on devices like our phones, keeping raw data local and private. However, it has a big problem. It usually creates one single model for everyone, which struggles when users are very different from each other. Imagine one language model trying to serve both a doctor and a lawyer. Their vocabularies are worlds apart. This is the gap the CLoVE paper brilliantly addresses. Instead of one model for all, the researchers propose grouping similar users together and training a custom model for each group, a strategy known as clustered federated learning. The central mystery, of course, is how to group these users without peeking at their private data. The answer is surprisingly elegant. The method, CLoVE, works on the idea that you can learn about users by observing how a model fails on their data. Think of it like a teacher giving a test. Students who learned from the same textbook will likely struggle with the same questions. CLoVE applies this logic to AI. It sends a model to a user's device and measures the pattern of errors, or loss, it produces. This error pattern is converted into a compact signature called a loss vector embedding. The system then simply groups devices that have similar error signatures. Once these clusters are formed, the federated learning process continues, but now each cluster collaboratively trains its own specialized model. The researchers show this is incredibly effective. A key advantage of CLoVE is its simplicity and robustness. Unlike other methods that need a very good starting model to work, CLoVE can figure out the clusters accurately even from a poor initial model, making it much more suitable for messy, real-world scenarios. The experiments in the paper demonstrate that CLoVE identifies user clusters with high accuracy in just a few rounds of training and achieves best-in-class performance on a wide variety of tasks, both supervised, like image recognition, and unsupervised, like pattern discovery. While this approach is a major step forward, the ultimate challenge for any such system is determining the ideal number of groups to form. CLoVE streamlines the how of clustering, but deciding whether your users fall into 3 groups or 30 remains a critical design choice. Still, this research opens the door to a new generation of personalized AI that adapts to our individual worlds without invading our privacy. It pushes us to ask a fascinating question. What if the future of personalization isn't about apps watching what we do, but about them learning from the unique ways they get us wrong? If you enjoyed this breakdown, don't forget to like, comment, and subscribe for more AI research made simple.